What is a Secchi disc? A Secchi disc is a simple tool made from an 8-inch diameter disc colored black and white. It is used to measure water clarity in deep bodies of water. But why is water clarity important to measure? Well, according to the Minnesota Pollution Control Agency, soil, or sediment, is one of the main pollutants in Minnesota lakes and ponds, and too much sediment in the water can be harmful to fish and aquatic insects. In addition to potentially harming aquatic wildlife, too much sediment in the water can make it unpleasant for humans to look at or use the water for recreational purposes. And furthermore, excess sediment can make the water undrinkable without going through costly treatment. Rainwater can wash sediment directly into lakes or into rivers and streams that eventually flow into lakes, potentially affecting water quality in all our water resources. However, water that is too clear can also be a sign of problems, as it may indicate a lack of nutrients necessary to sustain aquatic life. So it is important to monitor the condition of all our lakes and streams. But monitoring water clarity across Minnesota's lakes and streams is a big job. Fortunately, kids just like you can help. Water clarity monitoring programs, like those supported by the Minnesota Pollution Control Agency, rely on volunteer efforts from community members of all ages. In part 1 of this 2-part video series, 2 Minnesota scientists will discuss how the Secchi disc is important in their research. We will also show you how to use a Secchi disc properly. So let's meet our scientists and learn how the Secchi disc is used in real-life science.
My name is Audrey. I'm a PhD student at UMD's Large Lakes Observatory. I research how invasive mussels, like zebra mussels, impact the Great Lakes. So one of the ways that they alter lakes that they have invaded is by making the water a lot more clear. So zebra mussels are filter feeders, which means they suck in a whole bunch of water and eat whatever is in that water before expelling it back out. So like little bits of algae and other organic matter, things that we call detritus. While a lot of people may think that clear water is a good thing, it can actually lead to negative impacts like less food availability for other animals like fish, or an increased growth of algae that grows on the bottom of lakes. One of the ways that we look at how water clarity has changed in invaded lakes throughout the years is by using a Secchi disc. So a Secchi disc is a circular plate that is painted with black and white sections and has a weight on the bottom. And using a rope, we lower it down into the lake and record how deep we can lower it until we can no longer see it. And that can show over time how that depth changes, shows how much light penetrates into the water column. Clearer water tends to have less food for other organisms, and it can also affect prey species. They can be seen a lot easier. It can increase nuisance growth of algae on the bottom of the lakes. While I study how mussels affect the water clarity of lakes, there are lots of other researchers, even some here at the LLO, the Large Lakes Observatory, that study how water clarity then impacts other organisms living in the lake.
Name is Kirill Shapov. I'm a PhD candidate at Large Lakes Observatory, University of Minnesota, Duluth. My research is about seasonality and how lakes are different in different seasons throughout the year. I'm studying small and big lakes like Lake Superior. I'm especially interested in wintertime and what's going on under the ice. The winter is kind of understudied season, and we're trying to cover this season. I'm looking at small organisms like phytoplankton, and those are the aquatic plants. And zooplankton, those are crustaceans, or we call them water fleas. So phytoplankton and zooplankton are important part of the food web in any lakes. And for example, phytoplankton eaten by zooplankton, and zooplankton is one of the main food sources for different types of fish. In my research, I'm using different kind of tools and equipment, and one of them is the Secchi disc. As Audrey said, she's looking at the transparency and how the invasive mussels affecting transparency of the water. I'm looking in the opposite direction. I'm looking at the transparency effect on phytoplankton and zooplankton. And for example, if you take Lake Superior, and one of the stations that we sample 10 times throughout the year, we found that the lowest transparency or water clarity was in November, and it was about 9 feet, less than 9 feet. So it's quite low for Lake Superior, and if you take Lake Superior, sometimes the transparency can be 20 meters. So, and what's happened there, basically, in fall of 2017, there was a lot of rain, and that rain increased the river discharge. Those rivers brought a lot of sediment and other organic matters and make that water muddy or cloudy. And that makes fish unable to see their food, like zooplankton. And if you fish there, it's going to be hard to catch anything, and your fish is going to be not successful. Also, transparency important for water clarity is important for people, for the communities who live in that location and whose water intakes actually depend on that location. Secchi disc can give us this information. It can tell us what's that transparency, what's the water clarity, can people use that water, and for me as a biologist it's interesting in the way how it's affecting biota of the Lake Superior, like phytoplankton and zooplankton. So that's why Secchi disc is important.
A Secchi disc should be used in lakes or water bodies that are deep enough to make this type of device practical. Most of the time, they are used off the side of a boat or a dock. Here we see Audrey and Kirill preparing to use a Secchi disc to measure water clarity off of a dock. Audrey begins by slowly lowering the disc into the lake by the cord while watching the disc sink down into the water. When possible, avoid taking readings in glaring sunlight or heavily shaded areas, as this can affect the accuracy of your readings. When Audrey can no longer see the pattern on the Secchi disc, she will stop lowering it. Next, she will carefully raise it until the disc is just barely visible. Proper technique will include lowering and raising the disc until she has found the midpoint between the disappearance and reappearance of the disc pattern. Once she has determined the midpoint where the disc disappears and reappears, she will make a note of the depth of the disc by referring to the gauge on the cord, and Kirill will record the reading. Scientists collecting data will usually take more than one measurement at the same location and then average the data. Now it's your turn. Kids can do this too. Please be sure to watch part 2 of this video series to learn how to make your very own Secchi disc. Thanks for watching. See you next time.